What you're looking at is an anonymized demo environment of our Fleet Insights platform. This is where our users monitor the technical performance of the vessels. So think speed loss, propeller heaviness, specific fuel oil, charter party monitoring. And we've built this data quality module so that users can, at a glance, see the status of their data and if any action is needed. Right now, there are three main columns here, which I'll describe in this fleet overview page. One is a understanding if the data is actually available. So for the critical tags for performance, like draft, speed, consumption, is that data available or are we seeing an outage? The second column here focuses on outliers. So we have automated outlier detection. So if you think back to the slide I showed with the fuel consumption data, the blockage and the flow meter, we want to be able to automatically detect that and actually filter it from downstream applications. And so there's a high level indication here which shows the amount of outliers our system is detecting. And then this last column here is actually focused on the speed log specifically. As I've mentioned, that's where we do see drift happen frequently. And because speed is the foundation to really any performance analysis, we wanted to create a specialized module and view on the quality of that speed log data. So I'll actually start there and I'll show you what this looks like for vessel 107, where we see the degrading quality of the speed data. So when you start to drill in here, you can see just the overall status. We're telling our users here that there's degrading quality. And the way that we're judging that is through this chart here called historical sensor quality. What we're doing is we're essentially following the difference between what the speed log is measuring and a derived version of speed through water using speed over ground and current data. And so the reason why we can compare those is because they're completely independent from the readings of the speed log. And we have an algorithm which over time is smoothing that data and computing the difference. And what we tend to see is if there's plus or minus 5% deviations, that could be normal noise and difference in these signals. But when we start to see anything above or below that, that's where we would start to alert users about degrading quality. You can see here, starting like in end of December, January for this particular vessel is where we've been detecting poorer quality fuel data. And when I actually just zoom into this time period, I can scroll down here and look at, oh, wow, okay, so here is actually the derived speed through water, and here's the speed log readings, and we can see a much more clear divergence between those two readings for this time period. If I want to zoom out and just see the bigger picture here, it becomes even more clear because you can see for most of this time period, which is almost about a year here, the readings are actually quite close together. But then more recently, this is where the divergence is happening. So that's quite clear. Not all vessels are like this. So, there's other vessels where we see consistently solid quality. So, for example, this one was experiencing some diversion that was probably recalibrated. And since May, it's been very smooth. You can see here, there's almost full overlap over these points. And so tools like this, especially when you're managing multiple vessels, really help you get a sense of where there are problems and where not. I'll quickly show you some of the other functionality here. So in addition to looking at the speed log, we have automated outlier detection for speed through water, shaft power, draft, fuel flow. And what we're allowing users to do here is actually configure vessel-specific thresholds so that if anything is out of the reality of the physical bounds of what the vessel or sensor should be doing, that's automatically tracked here. We don't just want to say, hey, there's an outlier. We're also building tools to manage these outliers. Right now, this vessel doesn't have any, but when you do have those outliers, they're listed here, and our users could actually acknowledge or remove them depending on if they believe it's actually an outlier, or if they just say, forget it, keep it in the system and keep it in my calculations. If they do remove it, other parts of our platform that monitor speed loss or fouling, for example, will have that data removed so the calculations are more trusted. And also because, there's a lot of users at some of the companies that work with us, maybe 10, 12 people, we want to have an action log here so that if I remove a data and somebody from my company logs in, they can also see that action and actually undo it if they believed it was a mistake. And then last but not least, I'll just show here quickly data availability. As I mentioned up front, this is looking at the current status of these core signals like shaft power, draft. If the engine has two specific main engines and two shafts, we separate those instead of giving you an aggregate reading. And then if the vessel doesn't have a sensor, like here, we just show an X, so it's not configured. But what this is helping our users do, especially with the fleet overview view here, is at a glance for your vessels, get a quick sense of where I need to take action and where not.